Hello everyone, good morning. Today we will be looking at the basics of trigonometry. So in this session, I will take you through all the basic formulas, the identities that are there in trigonometry, what are the basic angles, what are formulas with regards to the sine, cosine, tan, and so on. So, what is trigonometry? Trigno refers to triangles and metry refers to measurements. So, basically, it is the measurement of the angles of triangles which is referred to as trigonometry. And when you talk about triangles, we are talking about right angle triangles over here. What is a right angle triangle? A triangle in which one of the sides or one of the angles is 90 degrees is a right angle triangle. So now you can see the ABC, which is a right angle triangle. So when we talk about right angle triangles, the first thing that comes to our mind is Pythagoras theorem, that you would have learned this in some of our earlier classes. And what does the Pythagoras theorem state? It states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if you look at this, so it is AC squared is equal to AB squared plus BC squared. So it's pretty clear how the Pythagoras theorem works with this using this figure. So in this right angle triangle, suppose I would like to introduce these three terms with respect to this right angle triangle. They are the sine of an angle, cosine of an angle, and tangent of an angle. So what is sine of an angle? Suppose I say sine of angle A, and what does the sine of angle A refer to? It is nothing but the ratio of opposite side this angle. So this is CB. BC is opposite to this by the hypotenuse. So opposite side by hypotenuse is the sine of the angle. So and similarly cos. So suppose theta is the angle, then sine theta would be opposite side by hypotenuse. Similarly cos of an angle is equal to adjacent side. So if you're taking cos of this particular angle, then the adjacent side AB by AC would be the cos of this angle. And what is tan theta? Tan theta is nothing but opposite side by adjacent side. So in this case, it would be BC by AB. So this is the basic definition of sine theta, cos theta, and tan theta. Going forward, then there's a quick mnemonic to remember this. Sokatoa. So what does that? Sokatoa mean? Sokas. So SOH. So this SOH that you see over here, this SOH is nothing but sine is equal to opposite by hypotenuse, and cos is equal to cos of an angle is equal to adjacent side by hypotenuse, and tan of an angle is equal to opposite side by adjacent side. So that is how you can easily remember the formulas for sine, cosine, and tan, or the tangent of an angle. So going forward, let's see what are the other relationships which are there. So there is something known as cosecant. What is the cosecant of an angle? That is nothing but the inverse of sine. So C and S, they are always inverse. Suppose you see, and then cosecant is equal to 1 by sine, and then here, what is secant of theta? So secant is equal to 1 by cos theta. And next we have cot theta, and cot theta is equal to 1 by tan theta. It's the inverse of tan. So the inverse of sine, cosine, and tangent. So we see these three are equal to cosecant, secant, and cot respectively. So now what have we seen till now? We have seen the Pythagoras theorem. Hypotenuse square is equal to the sum of the squares of the sides. Then we have seen sine of an angle, cosine of an angle, tangent of an angle. What are the formulas for that? That can be done using the mnemonic SOHCAHTOA. And then we found cosecant, secant, and cot. So cosecant is nothing but 1 by sine, secant is nothing but 1 by cos, and cot is nothing but 1 by tan. Going forward, now there are certain basic angles for which these need to be known. So those angles are the 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The value of sine, cosine, tan, cosecant, secant, cot, we need to know all these for use in various problems. So there's a, suppose you don't know anything, you just are going in and you wonder what are these values. So there's an easy way to remember this just by remembering one part. So sine, if you look at sine A, so suppose and A can have these values 0, 30, 45, 60, 90. Suppose you were to write this down. So sine A for 0, whole square root of, you can write it as 0 by 4. Then 30, you write it as square root of 1 by 4. Then it is 2 by 4, the whole square root. Then square root of 3 by 4 whole. And then square root of 4 by 4. So in the first case, what does 0 by 4 become? It becomes 0. So sine 0 is 0. Sine 30 is square root of 1 by 4. The denominator square root of 4 becomes 2. It is 1 by 2 hence. So 45, it is square root of 2 by 4. So 2 twos are 4. The denominator becomes 2. Then square root of that, and it becomes 1 by square root of 2. And for 60 degrees, sorry, we have square root of 3 by 4, and the denominator square root of 4 becomes 2, and so sine of 60 is square root of 3 by 2. And then we have for 90 degrees, it is square root of 4 by 4, and so it is 1. This is a method to easily remember it or write it down. You could do that just before your exam, or you could do this, practice this for a couple of times, and then it just sticks in your head. And if you look at cos, it's just the inverse of this. So if you see 0, half, 1 by root 2, root 3 by 2, 1. So you just reverse it and write it over here, 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. It's just the reverse of that. And what is tan? Tan is sine by cos. So 0 by 1, 0. 1 by 2 by root 3 by 2, it's 1 by root 3. And then 1 by root 2 by 1 by root 2, 1. Root 3 by 2, it is by 1 by 2 is root 3. And 1 by 0 tends to infinity, so it is not defined. And that's why I have put a ND over there. Similarly, cosecant is 1 by sine. So these values you can easily figure out after that. So for cosecant is 1 by cos. So 1 by 1 is 1. 1 by root 3 by 2 is 2 by root 3. And 1 by root 2 is root 2. So, and go so on. And for cot theta is 1 by tan of that particular angle. So you could easily find that out. And I suggest that you do this every day for a few days, so that then this becomes second nature to you. And for those who are taking the board exams for 10th, be it CBSE, ICSE, I think these are things that need to be absolutely learned. And going forward, we have a particular identity, series of identities. Sine of 90 minus theta, which is equal to cos theta. And then you have cos of 90 minus theta is equal to sine theta. And if you look at it in the same way, then you go on to secant of 90 minus theta is cosecant theta, and cosec 90 minus theta is sec theta. And if you get tan 90 minus theta, cot 90 minus theta, tan theta. So these are very important identities with which various problems are there, and using this method you can, using the knowledge of this identity, you can solve them. We will do those problems in the coming sessions, but these identities have to be learnt, and that will be very helpful to you. And another set of very important identities, sine squared theta plus cos squared theta is equal to 1. It can be proved very easily by taking sine theta is equal to opposite by hypotenuse, and for cos it is adjacent by hypotenuse. If you just square it and you add it, you could do it as an assignment for yourself. Then you can easily prove that because the denominator and the numerator both comes to the same value, and they cancel out, and so the ratio is 1. So you can do this, try it out at home, and or I could prove that in a upcoming video. 1 plus tan squared theta, that is equal to secant squared theta. This is another one that needs to be kept in mind. So you, because it could you could use it in other ways. All of these ones can be used in various other ways, not just directly. They can be used in terms of tan, 1 secant squared theta minus 1 would be tan squared theta, or secant squared theta minus tan squared theta, that is also equal to 1. So various ways of using the same identity. Next one is 1 plus cot squared theta is equal to cosec squared theta. For these two identities, the value of the angle, or sorry, it's not a over here. It should be theta. It the so that would be greater than or equal to 0 and less than 90 degree, because at 90 tends to infinity in many cases. So this is very important. So just remember for your exams, these three identities are very very important. So mm, uh, I think today what we did was we ran through the entire gamut of the basic formulas that are used in trigonometry. One is the Pythagoras theorem, and then we looked at the formulas for the sine, the cosine, the tangent, and then how they are related to the cosecant, secant, and cot, and then what are the angles, how do you find the values of those angles from start, and then what are the basic identities in terms of sine 90 minus theta is equal to cos theta, and so on. And the last set of identities, which is sine squared theta plus cos squared theta is equal to 1, 1 plus tan squared theta is equal to secant squared theta, 1 plus cot squared theta is equal to cosecant squared theta. And for these two, the last two identities, 1 plus tan squared and 1 plus cot squared, the value of theta ranges between 90 degree and 0 degrees. So please use these basics and try to attempt the problems in your book. I will be doing future videos in which I will be solving quite a few of these different types of problems. So see you soon. This is Uni here from Mathemagic. Hope you enjoyed this video. Looking forward to see you again. Bye.